Assalamu alaikum everyone. Uh, I'm making this multi-sim tutorial for you all. Since I've told you that you need to bring your laptops in the lab for the multi-sim, but I've changed my plan. Better that I'll upload the tutorials every week regarding the multi-sim, and you follow those tutorials and complete the circuit. Here, after that, if you have any problem, then feel free to ask. The link of the multi software is on your Google Classroom. Laptops or today's experiment that we'll be doing is Ohm's law and series circuit. Section 1C and 1D have done the theoretical calculation of Ohm's law and series circuit. However, section 1A and 1B has not done it since Thursday was the day off. The next Thursday, I'll teach them what we studied, and but in the next week, I'm expecting all the sections those all the sections to view this tutorial and then do the work that has been asked to do so that you can complete the manual. And 1C and 1D, you have done your theoretical work, see this tutorial and complete the one that's remaining, that's the multi part. Complete it and bring the complete manual in the coming class, that is coming Tuesday and coming Wednesday. For 1A and 1B, what you need to do is just see this tutorial, do the only part that is the multisim part, and then the rest I'll make you do in the class. Okay. So if you have successfully downloaded and installed the multisim in your software, when you open this multisim video, it will look like this. It will open like this. Okay. And the topic that we are doing is Ohm's law in series circuit. Ohm's law is nothing, just a formal implication of V is equals to IR, which means volt potential difference applied is directly proportional to the current in the circuit, keeping the resistance of the circuit constant. This is what the Ohm's law means. And in series circuit, there's just two things that you need to remember. First thing, that the current throughout the circuit remains same. In a series circuit, the current throughout the circuit remains same, and the equivalent resistance is the sum of all the resistance present in a series circuit. For example, if there are 3 or 4, 5, 6 resistance in series with each other, so how you will find the equivalent resistance or the total resistance? Basically, just add all the values and you will get the equivalent resistance. So this is the circuit that we will be doing today. Here is the three resistors R1, R2, R3 with three different values. You have a V source here. Okay. What you need to find? You need to find the current and the voltage of the series circuit, and we'll be implementing this circuit on the multisim, and we need to complete this table. This table means there are two things: current measured value and current theoretical value. The theoretical value will be doing with the help of calculation that would be done in the class. However, I expect everyone to see this tutorial and complete this table, the current measured value table, by seeing this tutorial and complete this table, the value that is coming in the multisim software. So how we will be doing this is simple circuit. So we go back to the multisim file. The multisim file, how do we place the components? We write here, go to place components, and then we write here the value. Let's say for you need resistor, so we write resistor. Okay, the rated resistor, and we press once. Then we press, since we need three resistors, and we get one. The other three resistors to get. Other thing you need to get is DC power. So you write DC, and the fourth one is here DC power, the DC source. Select this one. The last thing that you need to find is the ground, because you need to ground your circuit. Okay, so all the components has been chosen here. How to change the orientation of any circuit? You just select the circuit with the component, right click and rotate it 90 degrees or anything, as required. How we will connect this? Just press it here and press it here. There's a wire connection. Simple, like here, this one, Here is this your circuit has been made. The last thing that you need to do is the connect the ground, and your circuit is complete. So the value of the resistance here is 1, 1.5 and 6.8. So 1, double click on this where it's written resistance, write 1.5 here, and the third one also the value is 6.8, you write it 6 point, okay, like this is a little what you need to change the if you go back to this table, what you need to do is you need to change the voltage source continuously. First it will be zero, so when the voltage is zero, so everything would remain zero. When the voltage source is 1, so what we're going to do, double click on this one. From 12 volt we'll change it to 1 volt and you press it okay. Okay, you this green button means you need to run the simulation. Press it, it will start running. Here you'll see it's the how much time has passed. That's if there would be an error here in this multisim, there's some error will be shown if you have made any error. To stop this simulation, what we need to do, we need to find the current. So go here, there's a multimeter, select it and drop it here. In the series circuit, in the series circuit, you measure the voltage across the component and you measure the current in series. So you need to connect this ammeter in series. So what we're going to do is just connect it like this with one resistor and here with the source. This is your circuit is done. You just now the settings of the multimeter. Multimeter here will show you three things. A means ammeter to measure current. V means voltmeter, which means to measure the volt. This is a symbol of ohm, which means you need to measure the resistance. The bottom two, sine wave and the sine wave, means it's an AC source, and the dash means a DC source. Since we have used here the DC source, we'll select DC, and we need to measure the current, so we'll select this. Okay. Then we'll cross this. Then we'll run a simulation. Double click on this, and here's your current that is coming when you have applied 1 volt. Okay, so this current value you will put it here in the current measured value. Now what we need to do, we need to change the major voltage value to 2. Stop your simulation, double click on this, and for 1 just make it 2, press OK, and then run the simulation again, and the current has been changed. So this way you need to complete this table by changing the voltage source. Got my point? What do you need to do? You need to change the voltage source, the value of the voltage source, and complete the major value. Now, one thing that you need to take in account is that here the units are milliamperes, and here it's giving as microamperes. So you need to change the microamperes to milliamperes. Hope everyone knows how to change. So this series that we were supposed to do. So later on, in as time goes on, we'll be uploading more tutorials so that we don't waste the multi we do the labs. This multi-sim becomes your